Okay, so this is a set of linear equations. Again, you can see that x and y both have the power of 1 on them, which means that this is a system of linear equations. So we want to solve this by substitution or elimination. But we have fractions here and we have decimals, and so we are going to start out by getting rid of those nuisances. So to do that, we have our first equation has an 8 in the first denominator and a 2 in the second denominator. And so we're going to take the least common multiple of 8 and 2, which is 8, and we're going to multiply that first equation by 8. We're going to multiply every term by 8. In that first term, the 8 is going to cancel. In the second term, the 8 will cancel with the 2, and we'll end up with a factor of 4 left over. And then we will have 3x minus 4y equals 8. So we have simplified that first equation so that it is not difficult to deal with anymore. Now we're going to look at the second equation, and we have 2/10 x plus 6/10 y equals 4. So we want to multiply that by 10 to cancel out that denominator, or in other words, move the decimal one space to the right. So we have that equation. We're going to multiply everything by 10. So we're going to have 2x plus 6y is equal to 40. Now, I noticed right away that this equation has a factor of 2. Every number in it is even. And just to make this even more simple, I'm going to divide everything by 2. In other words, I'm going to multiply everything by 1/2. So x plus 3y equals 20. And that's not a step you would have to do, but it just makes things simpler if that happens to be the case where you have everything even. Okay, so now I've got my two equations in a much simpler form to deal with, and I can solve this system of equations. I'm going to use elimination. We have a 3x in the first equation, and we have an x in the second equation, so I'm going to multiply that second equation by -3, so that 3x minus 3x will be 0, so my x's are going to cancel out. So I'm multiplying this whole equation by -3. So the first equation stays the same. I'm not doing anything to that. Second equation becomes -3x minus 9y equals -60. So when I add those two equations together, the 3x and the -3x cancel, and I'm just left with -13y equals -52. And when I divide both sides by -13, I'm going to get that y is equal to 4. So I've got my y. Now I need to go back and find out what x is. So I'm going to plug that 4 in for y in the first equation. You can use either equation to find x. So 3/8 x minus 1/2 y, which is 4, equals 1. And then I've got 3/8 x minus 2 equals 1. And so 3/8 x is equal to 3, which means that x is equal to 8. So I've got my x and my y. Looks like 8, 4 is the point that I am getting for the solution to this system of equations, but I need to check it, and I'm going to check it in both equations. So first equation, I'm going to put in 8 for x and 4 for y. So 3/8 times 8 minus 1/2 times 4, and that's supposed to equal 1. So when I multiply that out, I get 3 minus 2 equals 1, and that is true. Now I'm going to try 8, 4 in the second equation. So 0.2x plus 0.6y equals 4. So 0.2 times 8 plus 0.6 times 4 is equal to 4. So 1.6 plus 2.4 is equal to 4, and that is true. So 8, 4 is the solution to this system of equations. Okay, number 13. We want to simplify this expression that has some i's in there, some square root of -1. Remember, I is equal to the square root of -1. Therefore, I squared is -1. I cubed is -I, and I to the fourth is 1. So we're going to remember our powers of I, and we're going to fill in the things we can fill in here. So first of all, I've got an I squared, which I just said is -1. So we're going to put that in, -3 times -1 plus 4i. So we've got that first two terms taken care of. Now that third term has the square root of -9. Whenever I have a negative number under the square root, I need to change that to Euler's notation. So the square root of -9 can be written as the square root of +9 with an I next to it. So -5 times the square root of 9, I. Now we've got -4 plus 5i cubed, and I cubed is -I, so I'm filling that in for I cubed. Now I'm going to multiply some of these things out. So -3 times -1 is 3, and then we've got 4i. And then we've got -5 times the square root of 9, which is 3, and I, and then -4, and then -5i. Now I'm going to add my real numbers, so 3 minus 4, and then I'm going to add my imaginary numbers. So I've got 4i and -5 times 3i, which will be -15i, and then -5i. So I'm going to put those next. And now I'm just going to combine my like terms. So 3 minus 4 is -1. And then 4i minus 15i minus 5i is -16i. And so that is the answer. Real part first, -1, minus imaginary part, 16i. Okay, number 14, we have the square root of 9 square root of 3. So we're going to change all of these square roots into fractional exponents. Remember, whenever we take the square root of a number, we could also do that in different notation by just raising whatever that number is to the 1/2 power. So I'm going to raise something to the 1/2 power, and that's all the things that are under the square root, the big square root, and that would be 9 square root of 3. So I'm going to just take the stuff that's under the big square root, I'm going to put it in parentheses, and instead of writing a square root sign, I'm going to write that as raised to the 1/2 power. All right, now I'm going to write both of the things that are inside the parentheses as powers of 3. So 9 can be written as 3 squared, and the square root of 3 can be written as 3 to the 1/2. All right, and all of that is still being raised to the 1/2 power. Now I'm going to use my rules for exponents, which tell me that when you raise a power to another power, you multiply the exponents. So I'm going to have 3, that first thing, raised to the 2 times 1/2. And then I've got 3 to the 1/2 times 1/2. Now I'm just going to multiply those out. So 3 to the 1 times 3 to the 1/4. Now I am multiplying like bases, 3 and 3. And that means I add the exponents. I do not multiply the 3 times the 3 to get 9. I simply add the exponents and don't do anything to the base. So the base is still 3, but I'm going to add the exponents, 1 plus 1/4, and that would be 3 to the 5/4 power. Okay, this is number 15 on your test. And in this problem, remember that the negative sign that is in front of the 16 is not being affected by the exponent because there are no parentheses here to indicate that that is part of the exponent at all. So the whole time we're doing this problem, we're just going to leave that negative sign on the left side, and we're not going to use it for anything. And just make sure it's there when we finish. All right, so first of all, we see that the exponent here is negative, which means we need to take the reciprocal of our base. So 1 over 16 to the positive 5/4. Notice once again that the negative sign in the exponent does not have anything to do with the negative sign in front of the 16. They don't affect each other in any way. So that minus sign in front of the 16 just sits there for this whole problem. So negative 1 over 16 raised to the positive 5/4. So all we do with that negative exponent is take the reciprocal of the base and change the sign on the exponent. All right, now what does 16 to the 5/4 mean? It means that we have 1 over 16, the fourth root of 16, so the number in the denominator is the root that we're taking, so the fourth root of 16, and the 5 tells us to raise that to the 5th power. So that is negative 1 over, the fourth root of 16 is 2 because 2 times 2 times 2 times 2 is 16. So negative 1 over 2 to the 5th power. And when we multiply 2 by itself 5 times, we get 32. So we have negative 1 over 32. And that is the answer to that problem.